Welcome everybody. We're going to give everybody another minute or two to join. So stick tight. For those just joining, we're going to give everybody a minute or two to get in. There's a little delay getting in through Zoom, so. All right, well, we could probably go ahead and get started, and anybody that kind of trickles in can join us in process. We are going to be recording the session, so they can always catch anything that they missed early on. So let's go ahead. Just wanted to welcome everybody. This is a session about the DC Water and Sewer Authority and how they're using a modern data platform to ensure data quality. And to support some of their other data-driven initiatives. So hopefully you're in the right place. My name is Jared Brown. I'm the Vice President of the Data and Analytics Practice at Talon. With me today is Joe Geisner, who's our Senior Vice President of our Government Systems Practice. Before we jump in, feel free to post any questions that you might have in the chat. We'll try to address them during the session if they're relevant to that particular piece, or we may save some of them for the end, or if there's any that we miss, we'll address them at the end as well. We're encouraging folks to use the Zoom chat, and you may have also seen there is a chat in the Pathable page. So we'll keep an eye on that, but it's a little more difficult to monitor, so bear with us on that. You may have also seen there's a couple of polls that we created just to get a sense of who's using what tools, technologies, and what kind of initiatives people are looking to undertake. So at your convenience in the Pathable window, feel free to respond to those polls, and we'll take a look at them later in the session. Okay, so I guess without further ado then, let me advance to the next page here. Okay, all right, so we're really excited to share our recent innovation in the water and sewer industry. And just to explain a little bit about our company, Talon, simply stated, we're a technology consulting company, so professional services with a focus on enabling our customers, other companies, mature their organizations through digital innovation. This is made possible by our investment in our different practice areas, including things like user experience, application development, cloud technologies, and of course, data and analytics. We're at the crossroads of technological advancement right now, and we have the scale of the platform and the availability of tools to take advantage of many, many new data sets that in the past would have been more challenging. So with the progression of this digital age, more of our customers are looking to leverage data and analytics to drive their innovation. And that's true in both commercial and government entities. So okay. All right, so I'm going to talk a little bit about some of the initiatives that we've undertaken for water utilities, and some distinguishing examples that can help companies like yours achieve your goals as well. So in this case, we're focusing on the water industry, as I had mentioned, but these patterns are widely applicable. So don't let the fact that we're talking about some of things that are water specific discourage you from trying to apply these same concepts to your industry. Okay, so the first thing I want to talk about is a water quality monitoring solution that we developed. Basically, that would allow DC Water and other utilities to capture data and perform some analysis and reporting in real time based on sensor data, things of that nature. So it would give them the ability to make corrective adjustments if there was a problem that needed to be addressed, or to kind of proactively address some customer service issues. The second item that we'll be looking at today has to do with meter reading information, but really it's just identifying anomalies in the data itself. So, looking at, historical patterns and seeing if there's differences that kind of manifest, or comparing one entity to another that is related, and seeing if things, might be indicative of equipment degradation or improper usage, such as theft. And then the last that we're going to look at is related to preventative maintenance. And in this case, we would look at historical data and see if we can detect, or predict rather, catastrophic failures of equipment, such as water mains, that could cost millions of dollars to fix if there was a a catastrophic failure. So this is obviously supported by a very economic benefit, but there's others as well, such as preventing natural disasters and things like EPA fines if there is a failure. Okay, so as you undertake any of these initiatives and kind of build out the modern data estate to support your organization, just keep in mind that every new data source or interaction with the data lake, it creates an opportunity for reuse and the potential to combine that information with other sources of data in ways that you hadn't perhaps not previously considered. Other departments within the organization might start to see value and want to participate in that growth. And with the scale of the cloud and the tools that are available, you'll soon be embarking on that next data-driven initiative. So that's exactly what happened with a recent customer of our engagement of ours, specifically DC Water. And that's a story I'd like to talk about a little bit today. Okay. All right, so first, I wanted to talk a little bit about who DC Water is. As you can see on the screen, it's actually DC Water and Sewer Authority, but they're delivering drinking water to the DC and surrounding areas in Virginia. They deliver 99 million gallons of drinking water a day, which is a pretty impressive number. And they're processing 200 to 300 millions of wastewater. That includes not only sewage, but stormwater as well. And they actually have the largest advanced wastewater treatment facility in the world, which is pretty impressive. And a byproduct of that facility is the production of fertilizer. So they're actually bringing in revenue and kind of supporting a lot of their initiatives based on creative thinking like that. They also support the city or the district in other ways, through the support of 9,000 fire hydrants. And as you might imagine, in addition to 700,000 citizens, DC is a hub of from a tourism perspective as well. So they support all those needs. All right. Just wanted to show DC Water's mission here and their vision, and you can see that their goal is not only to deliver the high quality services, but also to be environmentally friendly and provide all those services in a very efficient manner. They take very seriously the responsibility of this, so they're very proactive in the health and well-being of the people and their workforce. So proactively remediating any issues with lead pipes that remain. Some of their infrastructure actually predates the Civil War, so it's a really range, has quite a range in the infrastructure that they support. Okay. So I had mentioned their focus on innovation, and they had mentioned that obviously one of their goals is reducing the overall cost to serve the citizens, provide better management of the resources, one of them being water itself, which is certainly a one of the most valuable resources in the world. And then the last is to improve reliability and quality of the services they provide. This is all achieved through, or in their goal is to achieve this through combining silos of data and bringing in new data sources. Actually getting a little background noise. Okay, I think that's taken care of. Using AI technologies like machine learning to do those predictive analytics, and doing so in a way that they can leverage the rich visualizations that are needed to kind of see those insights and then take action on them. All right. Okay, so as we were working with them to make a choice on the tooling, one of the questions that came up is the reporting platform, and they chose Power BI. And just to list a few of the reasons, just because it's a familiar experience, Power BI is incredibly easy to learn, especially for folks that have used Excel in the past, which is pretty much everybody. Power BI has a very nice interactive experience that allows like self-service and ad hoc exploration of the data. It is, of course, a leader in the Gartner Business Quadrant. But one of the most important parts is the seamless integration it has with Microsoft and, technologies and a variety of other platforms as well. So I wanted to jump into kind of the end first, show you the final product of one of our initiatives, and then take a step back and show you how we kind of achieve this. Before I do that, does anybody have any questions, comments, or? Okay. Looks like a few folks had some trouble getting in. Hopefully they're in now. Looks like they might be. Okay. Okay. All right, so as they kind of embarked on their journey, they wanted to start small because they wanted to get familiar with the platform and the technologies. And things like this may seem intimidating, but we wanted to say that getting started doesn't have to feel like drinking from a fire hose, right? So DC Water's goal was to start small. Forgive the pun, but they wanted to dip a toe in to the technology and see if they could get some value out of that initial investment. So the first thing that we undertook was a case study focused on water quality monitoring. So here are the technologies that we use for this initial maybe like 3-week endeavor that we undertook with them. We pulled in some sensor data from their SCADA system, so things like chlorine levels, pH levels, cloudiness or turbidity in the water, along with pressure sensors, sensor data, and other measurements that they collect at their various pump stations throughout the district. We dropped that data in a data lake. And for those of you who are unfamiliar, you could think of a data lake as like a network share. It's essentially a location with, that's a place to drop files. And, you could have folders, depending on the style of data lake that you're using. And it's just a real easy way to kind of gather data that you want to do some kind of operations on. The data that we pulled in, even though it's IoT or sensor data, we ended up just grabbing it daily to start because we wanted to start small. But this architecture will, as you'll see, lend itself to more advanced data collection options in the future, such as streaming the data. From there, we ultimately wanted to visualize this data in Power BI, but we first wanted to look at those values and create a forecast on that time series data so that they would have an indication of, based on historical operations, which way those readings were going to go, and that would give them the opportunity to take corrective action. Okay, so now I'm going to actually jump into a demo and kind of show you what we ultimately produced. Let's see. Okay. Too many windows here. Here we go. Okay, so this is the final product in our Power BI environment. I should say near the final product. This is using some test data, but what we gave them the option to do is to look at 3 of their pump stations. So we have, Alaska Street, Anacostia, and Bryant Street. And for each of them, look at some of the different measurements. So you have chlorine that we're seeing now, pH, turbidity. But the idea is that they wanted to not only see the historical data, and this is showing the last 2 weeks. I mean, since this is a different environment, we only pull the data in weekly, so that's why you're only seeing up to December 2nd. But we also gave the ability for them to see this forecast, where the data is likely to go based on historical information. And we gave them some upper and lower operating ranges as well, so that they could kind of use this as an opportunity to set proactive alerts. So Power BI would let them say if the forecast or the actual values go outside of that operating range, they want to get a notification, whether it's an email or a push notification on a mobile device. This would kind of facilitate that. Now, we could have done this forecast in Power BI. Power BI has integration with R and Python and several other custom visuals that allow forecasting capabilities, but we wanted to keep all the historical forecasts as well, so we could go back and evaluate them. So that's why we ended up using, as I had shown in the previous diagram, Azure ML services to do that forecast. And I'll show you very briefly what that looks like. But that also gave us the ability, if we wanted to go back and look how forecasts were over time, you could see I could drag this around and see how well the forecast was on any particular day. Okay, so let me show you a little bit about the technologies at play behind the scenes here. So here is an Azure environment. Notice this is our DC Water Data Science data lake. In a data lake, you have what are called containers. I took the liberty of opening one of those here already, and let me close this actually. I think my Zoom dropped that off the screen. There we go. So hopefully you could see here, but in the data lake under water quality input 2020, and I could click through some of these. Under 2020, we'll have a number of months. Oh, there's the X, there we go. And then if I just pick a particular date, let's go in here and just pick one of these CSV files. So these are the files that we're getting nightly. I have the ability to view that data. And you could see here, for each of these points in time, we have sensor readings for chlorine, pH, temperature, turbidity, etc. Just as a CSV file, so comma separated file for folks that don't know. And they're separated in this case by year and month, but in a scenario where you're streaming the data in, we may just have like running totals or files that get appended onto, and you could still have the same level of partitioning, but it is definitely a possibility. So what we created to do that prediction is a small piece of code. I'm in Azure ML services right now, and this is the designer view. You see they have a whole bunch of examples that you can click on to see how they work. Ours, rather than using some of the drag and drop features, we actually wrote some Python code. So data comes in, we execute a Python script that reaches out and grabs some of the information from the data lake that we want to process. We do our actual time series forecast, and then we write it back out to a data lake in this script. I'm not going to go through the details of that, but I just wanted to show you the tool real quick. And since I had mentioned, there's a lot of these sample data sets you could come through and experiment with. So if I click on just one of them that I think I opened before, you'll see in this case, they make a lot of these things kind of drag and drop. So, in this case, they're using a decision tree to predict an adult's income based on certain demographic data. They train the model, and then with half of the data in this case, and then they see how close their predictions were. This is meant to be a very kind of user-friendly approach to machine learning. But as you could see, if you want to run your own Python or R or other scripts, you have that flexibility as well. All right, so back to the water quality example. After data comes in and we do those predictive analytics, we actually write data back out. So you see we have our predictions writing back out to the data lake. Same kind of idea, just has those forecasts, and we store these for every single day as well. Okay. So what that ultimately resulted in is what you saw here in Power BI. And let me just make sure there wasn't anything else I was going to mention. Oh yeah, the one other thing I did want to add and highlight is we have another page that's hidden now, but you can actually set up those alerts and thresholds. Let me see if I can actually show that real quick here. Oh, that was the wrong one. All right, hold on. All right, so what I'm showing you now is kind of the data lineage that Power BI provides out of the box. So we have our water quality forecast report. You can see that's based on this water quality forecast data set, which is based on that data that's sitting in the Azure data lake. So you can kind of see how the data flows. And downstream from this forecast, we have a threshold deviation and a water quality monitor dashboard. So if I just go to one of those real quick, you'll see here for each of the locations, well, this one is in the test environment, so it doesn't actually have any information to display, but the idea was to show some of the most recent readings. Let me see if the other one does. It was this one. Yes. And if anything came out of range. So in this case, you'll see if any of the Bryant Street chlorine level was out of range, it would trigger this KPI, and a operator has the option to add an alert. So I could say if the chlorine is above the threshold of 0, send a notification, and maybe email me as well. So you really have kind of a great facility here to look at kind of taking proactive corrective action if there is some kind of a threshold alert. Now, of course, a lot of the infrastructure and systems that you're using for capturing those sensor readings have some of their own alerts and thresholds, but if they don't, or if there's something that you want to do where they don't have, for instance, that forecast data, they wouldn't be able to say the forecast is going to be outside of the threshold. In this case, we could. So that was kind of the impetus behind this. All right, so let me go ahead and open up Power BI Desktop just to show you something that I was working on. Okay. So because we were pulling from Power BI all those files from the data lake, I mean, and if you think about it, I mean, right now, there's potentially hundreds of files, and for each pump station, you have new files every single day. Pulling all those files and operating over them started to be slow. And I say slow, but the time it would take to refresh that Power BI report each day was 15 minutes. And not that that's that bad, but as you bring in more data, it may slow down, pulling more and more files. So we wanted to, as they kind of embark on taking this pilot to a more robust level, look at ways to optimize that performance. So let me just get a couple things going here. I'm going to switch back to the slides. Okay. All right, so we finished that pilot engagement and they were happy, but now that they had a handle on the technology and what could be done, they wanted to do more. So not only are we continuing to do more work on that water quality pilot that I'll talk about in another second, they took on two other initiatives, one related to the water main breaks and one related to large meter alerts. And not only that, it created like a energy in the company where next thing you know, the customer service folks wanted to leverage the platform and some of the data that we were kind of harvesting for some of their initiatives. So once they effectively understood the technology, they wanted to kind of step up and kind of embrace a more enterprise level data architecture. So what I'm showing here, you'll see has some echoes to the original simple architecture we used. You still have your data coming in through Azure Data Factory, ending up in the data lake. But we added were a couple other things. We added Azure Databricks, which is a platform that allows kind of more advanced ETL or transformation operations to occur. It's a more kind of robust platform for authoring some of those ML machine learning workloads, doing that exploratory analysis, and pulling in data from a variety of sources. So you notice you have the option to pull in streaming data through a platform like Databricks. The other thing that we added is Azure Synapse Analytics. Now, Azure Synapse Analytics, you may have heard there was a recent announcement that it and all of its features went generally available earlier this week, but it's a few things. It's a data warehouse platform, so just like a normal SQL database, but able to handle massive scale data. It's also a workspace or an ecosystem that allows folks to get in and do a lot of the things that we have been talking about today in a single location. And I'll show you what it looks like. I'll show you what it looks like in a moment. It also has a layer that allows tools like Power BI or any other reporting platforms to query data that's in the data lake, but rather than pulling individual files, it creates a like almost a metadata or a SQL-like layer, a database-like layer on top of the data lake. This is a pattern that's becoming very popular recently, and it's sometimes referred to as the data lakehouse, which is you'll see has a very powerful implications. Okay, and then in terms of the data lake, and you saw some of this as I browsed through the files, one of the important things to consider is when you are storing data in a data lake, you may have heard the term data swamp and some of the negative connotations associated with that. It's really important that you structure the data in the data lake in a way that's organized, so that things can be secured, findable, and you'll notice I allude to some folder structures here that we suggest using as the data comes into a raw area, is further enriched and refined, and ultimately moves into a set of curated folders. These folders would be similar to what one might see in a data warehouse. And in fact, you have two options at this point. You could pull that data into the data warehouse and report on it using tools like Power BI. You could actually bypass the data warehouse and query the data lake directly using that data lakehouse pattern. But you also have a benefit when you're using a data lake for folks like data scientists and analysts who want to do experimentation on that data, and maybe in some cases the raw data before quality issues were removed, because they might be looking to do some analysis on the accuracy of data and whatnot. So this this new platform really provides benefits to a variety of users, from the very technical data engineers, data scientists, all the way through analysts, executives, using a very kind of familiar and common experience. Okay. All right, so let me go ahead and open up Power BI and show you a few things. Let's see. Oh, this is the wrong one. I apologize. While I bring up the other file, does anybody have any questions? Okay. All right, so as I had mentioned before, that Power BI report that we looked at was taking about 15 minutes to refresh, and that's only with 2 years of data. So they wanted a approach that would be like more enterprise. So let me go ahead and instead I'll show the data lake itself. Okay. All right, so I'm opening up another window here. This is in Microsoft Azure, and hold on a second. Let me zoom in a little bit. Okay. And what I've opened is called Azure Synapse Analytics. And just to show you what it looks like, is it's a single location where you have the ability to operate on your data. You can ingest it, you pull it in from a variety of sources, you can explore and analyze, you can actually visualize directly in this platform using Power BI. And then there's a variety of other data sets and tools you could use to kind of get familiar. Okay, so if I go back to the workspace itself, I'm going to run through a number of tabs here, and let me start at the beginning. Okay. All right, so on the left, you'll notice I have a data tab, a data menu, a develop menu, a pipeline menu, and then some administrative menus down here for monitoring and whatnot. To start, I'm going to look at the data panel here, and you'll see I have two things. I have my databases that are available to me, and this list could include things like Azure SQL, the Azure Synapse data warehouses, and we'll come back to these Spark databases a little bit later. I also have access to other linked data sets. In this case, I linked to the DC Water's data science data set. On the develop tab, I have SQL scripts, notebooks that I'll cover, and there's even some Power BI integration. So you could actually see your Power BI reports in this environment as well. To start, I'm going to look at this water quality ingest notebook. For those that don't know, notebooks, more probably commonly, our Jupyter notebooks are kind of an environment that allows a combination of both documentation and code. So you see here, I have this little block where I have some text that's describing what this notebook does. I have some setup stuff that I have hidden because it has some of the physical locations, and then I have some code that I'm going to run. But what this water quality notebook does is picks up those CSV files that we deposited into the raw area of the data lake, and it does a little bit of manipulation on them and then deposits them in the curated zone so that they could be more readily consumed by end users using a variety of tools. Just to kind of walk through what we do here is we say this is the structure of our file. There is an option where we could infer the structure or the schema of the file, but I like to spell it out explicitly. But what I'm going to do here is create it's called a data frame, where I read data from a CSV file that has a header. Here's the schema, the source schema that I defined above. I do let it know what the time format is, because as you know, sometimes you'll have month, day, year, day, month, year, etc. And this is where the file lives. So a very simple operation. You could see just a couple lines of code, and then I could say I want to display that data frame, and I also add here, I want to see what the original file name, where it came from, and I'm going to limit that to just 2 records. So you see here, this is our data that we saw, and way over to the right, you can see, the path to the file itself, or just part of it. So this is just to make sure I was able to connect as expected. And then what I'm going to do is write this back out to another location. So I added a year column, a month column, and the file name to the actual data. And I'm going to write it to another folder, my sensor reading folder, in a Parquet format. And Parquet is just another way of storing the data. It's not nice and human readable like a CSV file is, but it's optimized for analysis. You also see here, I said I wanted to partition this file by the location, the year, and the month. And I do the same thing with our forecast data, but I'm not going to go through that list. Right in this same environment, I could go back to my data tab, go to my data lake folder. And in this case, I already navigated here. So it's under data lake, Sandbox, Jared, sensor reading, excuse me, sorry. And just to take a step back to see, notice when we said we partition by these different location names, you get a folder name that has the location, you get a folder name that has the year, and you get a folder name that has the month. And within there, you have the Parquet files. Now, these are named very, kind of arbitrarily, so you don't worry about the name. But one thing that's kind of nice is I can right click on this and say, let me select the top 100 rows from this file. You have a lot of other options. There's actually some new machine learning options that are available, but I'm going to show you one of those. This is what the file would look like when when I said select the top 100 records. So it says select top 100 from, notice it says open row set. It lists the location of that Parquet file that I had picked. And, I went ahead and removed the name of the location, but it actually would let me run this query and get that data back using a very familiar SQL syntax. I have another version that I went in, oops, excuse me, I went in and ran this same query, but notice that in this case, my scroll bar is not working. In this case, I said I want all locations, all years. This little star means all months, and all files. So I could actually run a query against the entire data lake folder of my choice and pull back all the records in one pass. Now I had run this before, but oh yeah, there we go. There's my results. So this query ran in 18 seconds and it looked at almost 100,000 records, so not too bad. This query ran in 1 second and pulled back the first 100 records. So you could see you have a nice ability to explore the data lake with a variety of familiar tools here. Any questions about this? Okay. So the next thing I wanted to talk about was, it's great that we, can write queries in this environment, but what else can we do? I can go in and write Python against this. So just like I had done before, I read in the Parquet file, and I could say display, 3 records from that file. I can do aggregation. So I could say, give me the average chlorine pH values and display results like this. And I could do other types of aggregations as well. So in this case, you see I show the average, and we have this kind of anomaly in the data here. This number is so small, it's 35 zeros right after the decimal place. So average might not be the best option. You could instead do something like a median. This is the median. You say a percentile approximate. 0.5 is the median number, and that gives a much more meaningful result. So just a quick example of the types of things you can do in these notebooks. For anybody that's heard of Databricks, this is a Spark notebook. This is exactly what the same experience that Databricks provides. This is just a little bit more kind of all kind of contained in a single environment. For real powerful analysis, I would at this point recommend using Databricks instead of Synapse Spark, but effectively it's the same exact idea. Okay. The last thing I'm going to show is now, it's great that we can run these queries using SQL or Python directly in Synapse, but what if I want to expose this data through Synapse, like I had alluded to earlier? One of the things that you can do using Spark is say, I want to create this database called Water Quality Monitor, and these are some preparation tasks, but notice I say I want to create a table called SCADA sensor reading using a Parquet location, and I pass in the location of my files in the data lake. So what this does is actually creates a table that I could query as if it were any other SQL database. But the data isn't actually stored in a database. It all exists only in the data lake. So you're creating a kind of an imaginary database layer on top of your data lake. So hence the term data lakehouse. And I could run queries against that. You'll see here I ran a query against that already, and it gave me the total number of records in each of those tables. I can run queries against those tables like you see here. This will take a second to run, but I haven't run this one before. But I can write pretty much any regular SQL against it. And if I didn't want to run this, oh, I did something wrong here. Oh, I highlighted something, I think. If I didn't want to run this, in Synapse, I could run this in Azure Synapse, or sorry, I could SQL Server Management Studio or whatever tool of my choice. So let's go ahead, and you see I get the results back here. Let's go ahead and see what I did in Power BI Desktop. All right, so Power BI Desktop, I wanted to recreate these files using, recreate this report using that Synapse database connection instead of the data lake directly. So you'll see here our sensor input, the source for this is a SQL database, and I'm hiding the server name and the database name, but you could see it lets me query this database as if it was an actual database. So I'm not going to make any changes now, but just to show you, I haven't refreshed this since September, but if I hit refresh now, this is going to reach out, query that database. I'm just going to move this over here because it does show the database, the server name. It has to establish the connections and whatnot, but in about 15 seconds or so, it should wrap up, and we should have the most recent data. While that runs, I'm going to bring over a version I published to the data lake, or sorry, to Power BI, which should be right here. This, you see, I published the September one. Notice that this is the same kind of report. I can, still navigate between the different pump stations and whatnot. One thing you may have also noticed, this Power BI report, I'm actually looking at in Teams. So for those who use Teams, you now have the option to embed reports directly, Power BI reports directly in Teams. You don't actually have to leave the Teams environment, which is fantastic. Looks like our report should be refreshed. It's just updating the visuals, and I do want to change this from 15 weeks to, I don't know, maybe 3 weeks is enough. The last 3 weeks, and there you go. So now we have data through the early December when we last connected. So so from 15 minutes to about 30 seconds, not a bad improvement. And oh, by the way, that query that I ran against that pretend database sitting on top of the data lake, I don't have to pay to have a database sitting around running. That was a query through what's called Synapse serverless, and they charge it per query you run, and it's about $5 per terabyte of data processed. So really a pretty cool, affordable option. Now, it doesn't replace the need to have a really robust enterprise data warehouse, but for some scenarios like this, it's a perfect fit. Okay, to wrap up, back on the slides real quick. DC Water went on to embark on some of their next initiatives. One of the next ones that they undertook was main break predictions. And here's a quick view of what the report looks like itself. We're probably not going to have time to delve in deep into the inner workings there, and I can't give away their trade secrets, but no, I'm just kidding. They're very, very willing to have conversations with other folks about their approach. But what we did was came up with a problem statement for them. Which water mains are likely to experience a break event in the next 6 months? We went back and further refined this to specific types of breaks, that are kind of more catastrophic and more costly. We grabbed a lot of historical data about main breaks themselves. We pulled in historical weather data. We pulled in traffic data most recently. So as you have like heavy vehicles driving over side streets because of construction and detours, that maybe have been an influence. We kind of prepared the data to make our prediction, ran the machine learning training piece, and then iterated. And we're going back and kind of refining that model, ultimately trying to get it to make a prediction of yes or no, there will be a break. And I'll say that we're over 99% accurate, but that's not really a fair statement to make, because machine learning models are going to look very heavily at the historical data, and if they just say everything is going to not break, then they're going to be right 99.9% of the time, because most water mains don't break. So we actually had to encourage the model to make some more aggressive break forecast than it originally did. And we're in the early stages of that project with DC Water, but they're very kind of excited about some of the potentials for that and other areas. I'm not going to go into a deep demo on this one, but if you are interested, you can certainly reach out. I'm happy to kind of talk through this in a little bit more detail. And just to kind of throw up this slide, if there's an initiative that you're interested in doing on your own, feel free to reach out to me. In some cases, Microsoft is willing to kind of collaborate, and we use like one of their programs called DPI 30 to effectively help customers build like a pilot platform in 30 days. So it's kind of great to kind of dip your toe in if you have some scenarios that kind of meet some of the criteria that we covered today. But any other questions? Feel free to throw them in the chat now. I know we have a couple minutes before we get cut off, but let's see. Let me see if I have any results on the poll. Okay, I can bring these over. Let's see. Is there a way to make this bigger? Just looking at the poll results here, one of them was different reporting platforms people are using. A lot of Power BI, a fair amount of Tableau, a lot of Excel. I still love Excel. I just saw last night that you can now create your own Excel functions and call them they're called Lambda functions. So some really cool capabilities there. Let's see the results on this one. Not too much. Just this one was asking what people are interested in terms of some of the things like self-service reporting, forecasting, anomaly detection. So it looks like we have self-service reporting, siloed data probably. So that's great. And let's see the results on this one. Looks like a 50-50 Azure and on-prem split between this one, although I think this is how we started off, so may or may not be representative of everybody who joined. That's one of the problems with pie charts. One of my user experience folks would have give me a hard time for picking that visual, because you can't tell how many people responded. But all right. Well, thank you very much. I'm just looking through the chat to see if there was any other questions, or if anybody wants, I think you're able to unmute and ask a question. I'll stick around until we get kicked off, but thanks everybody for coming. The recording I think will be available at some point, and I'll try to upload the deck shortly after, so you can come back and take a look at some of the slides we went over, but also feel free to reach out directly. All right. Yeah, and thanks Sarah for being the room host. Appreciate all the effort that kind of went into putting on this symposium and supporting.
Absolutely. Thank you. And thank you everyone for joining us.